Welcome to the lesson on lines and planes in three-dimensional space. In the first video, we are going to learn about vectors, direction vectors, and different ways to write equation of a line. These ideas are extremely important because they will be the foundation for planes and intersections later on. So in this lesson, we are going to cover a lot of the basic knowledges. First, we will talk about what vector actually are in two-dimensional and three-dimensional space. Then we will look at the position vectors and how to find direction vectors between 2 points. After that, we will explore three common forms of line equations, which means the vector form, the parametric form, and the symmetric form. And finally, we will take a quick look at the basic ideas of a plane, so we are ready for the next lesson. So let's start with vectors. A vector is simply something that has magnitude and a direction. In two dimensions, we read a vector like angle brackets AB, and in three dimensions, we read it like angle brackets ABC. For example, the vector spelled angle bracket 2, -1. It means point 2 unit in the x direction and -1 in the y direction. A position vector works similarly. If you have a point P with coordinates spelled x, y, z, the position vector is read as angle brackets x, y, z, which means it goes from the original to P point. If we want a direction vector between 2 points A and B, we subtract the coordinates, so we see vector AB equal angle brackets x2 minus x1, y2 minus y1, z2 minus z1. This gives us the direction points from A to B. Now, let's talk about the vector equation of a line. If we want to describe a line in three-dimensional space, we need two things, a point on the line and a direction vector. We write the equation as r equal r naught plus tv. Here, r naught is a position vector of the point on the line. V is the direction vector, and t is the parameter that can take any real value. As t changes, the point moves along the line. When t is 0, we are at the starting point. When t is positive, we move forward along the direction vector. And when t is negative, we move backward. From the vector equation, we can break it down into three separate equations. One for x, one for y, and one for z. We read them like this. X equal x naught plus a times t. Y equals y naught plus b times t. And z equals z naught plus c times t. These are the parametric equations, and they show exactly how x, y, and z change, and the parameter t changes. This form is super useful for line to plane intersections because we can substitute x, y, and z directly into a plane equation. So here is vector form, parametric form, and symmetric form. If the direction vector has no zero in it, we can also write a line use the symmetric form. We read it like x minus x naught over a equals y minus y naught over b equals z minus z naught over c. This form is great when we want to compare two lines to see if they are parallel, because the denominators tell us the direction ratios. So in two-dimensional space, we also have the familiar Cartesian form of a line. We can read it as y equals mx plus b, or ax plus by plus c equals 0. But it only works for lines in 2 dimensions. In 3 dimensions, one equation like ax plus by plus cz plus d equals 0 actually represent a plane, not a line. To describe a line in 3-dimensional space using Cartesian equation, we need 2 planes at once. So before we end this video, let's take a quick look at planes. A plane is a flat, infinite surface in 3-dimensional space. It has a normal vector which we read as angle bracket ABC. This vector is perpendicular to the plane and determines the plane's orientation. We will explore the different plane equations more fully in the next video. If a plane has a normal vector spelled ABC, and it goes through a point P naught spelled x naught, y naught, z naught, we can write the plane equation using the point norm form. The idea is that the vector from P naught to any other point on the plane must be perpendicular to the normal vector. This gives us the equation we will learn fully later. So here shows everything for we learned of lesson 1. We covered vector, direction vectors, and the vector parametric and symmetric form of a line, and the basic idea of a plane. In the next video, we will explore how lines and planes intersect and how to find distance in 3-dimensional space. So thanks for watching.